On PSC1-3, we're going to use different shortcuts to tell that two triangles are similar, and then use those shortcuts to find our missing side lengths and missing angles. So AAA similarity is our first shortcut. We can also just say AA, because if we know two angles, then we know the third in a triangle, just by subtracting from 180. But if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Okay, remember, similar triangles are going to be same shape, not necessarily the same size. I can also do the same thing with my sides, so have all three sides known. So if three sides of one triangle are proportional to three sides of another triangle, then the triangles are similar. In this one, they don't need to be congruent. I could have something like a triangle with 1, 2, and 3, and then another that's 2, 4, and 6, and those would be similar triangles. I can also do side angle side similarity. The important thing when I'm using this shortcut is that the angle is between the two sides. Okay, so I also write it that way. So two sides of one triangle are proportional to two of another, and the included angles are congruent, then the triangles are similar. So if I had a triangle like this, and this was 2, and this was 1, and this, let's say, is 40 degrees, and then I have another triangle where this is 4, and this is 2, and the angle sandwiched between them is also 40 degrees, then I know those triangles are similar. All right, so using this, I'm going to look for triangles, and I'm going to try to make sure first that they are similar. I'm going to prove this one using angle, angle, angle. This red angle is half as big as arc AB, but this red angle is also half as big as that same arc. So my red angles are the same. My blue angles are vertical angles, so they're the same. And then I can prove that these yellow angles are the same, either because subtracting from 180 degrees will give me the same thing, or for the same reasoning we used on those red angles with those inscribed arcs. So I have these two triangles similar by angle, angle similarity. Looking at this, the 8 and the 6 are in the same relative position. They correspond to each other. They're both between a blue angle and a yellow angle. So these triangles are kind of being folded into each other. 6 to 8 then has to be the same thing as 7 to x. And now I can cross multiply and divide, and I get that x is 9 1/3. All right, looking for x and w in this one, similar idea as before. We're going to make sure that our triangles are similar using one of our shortcuts, and then we're going to fill in our missing sides. I have parallel lines up here and down here, and they're being cut by a transversal, or actually by two transversals, which means that this red angle and this red angle are alternate interior angles. Same reasoning then. This blue angle and this blue angle are alternate interior angles. And I can prove my yellow angles either because they're vertical angles or because they are the third angles, and I know the other two in both triangles. So on this one, this triangle on the bottom kind of needs to be rotated to line up with the triangle on top. Okay, so the side that's 9 ends up matching up with the side that's 15. Okay, another way that I can visualize that is 9 is between a red and a yellow angle, so is 15. We'll solve for w first. 12 and w, again, are in the same relative position. Right, they're both between a blue and a yellow, or if I rotated that bottom triangle, it would match up that way. So I can cross multiply, divide, and I get that W is 20. Same strategy to solve for X. I have 9 and 15 as corresponding sides. X is in the same relative position as 21. You can cross multiply and divide. And X ends up being 12.6. Right, another example. In this one, I'm going to have this angle is in both triangles. I have a little triangle here, and I have a big triangle out here. So I automatically have 1. And then because I have these parallel lines, this side is going to act like a transversal. So these blue angles end up being in the same, or they correspond. So they're in the same relative position in those triangles. And then I can get my yellow angles either for the same reason, those parallel lines cut by a transversal, or because if I subtract 2 angles from 180, I'm left with the third. This entire side is 11, and this entire side is 4 plus x. Okay, that's important to know because I'm not using this trapezoid. That trapezoid is not similar to the little triangle up above. Okay, so I have to look at the little triangle and then the whole outside triangle. So 5 in my little triangle doesn't correspond to 6, it corresponds to 11. In the same way that 4 corresponds to 4 plus x. It's a really poorly drawn 4. I'm going to do my cross products here. So I get 44 equals 5 times 4 plus x, and now I just need to solve using algebra. So I have 44 equals 20 plus 5x. So 24 equals 5x. So x equals 4.8, or 4 4/5. To solve for y then, similar idea. 5 corresponds to 11 in the same way that y corresponds to 8. And then I can cross multiply and divide. And y, we're going to round and leave it as a decimal, even though it keeps going and it's kind of messy. Okay. All right, for on this one, we want to know, is PHY similar to YHT? So if that were true, P and Y would be the same, or PH would match up with YH, HY in this triangle would match up with HT, and PY would need to match up with YT. I'm going to use the Pythagorean formula here to figure out first what this height x is, and then what this little piece y is, and then I can check are all my sides proportional. So I know it's a right triangle, so then I have 420 squared equals 256 plus x squared. 400 minus 256 is 144. So x must be 12. Do the same thing to solve for y. 225, 15 squared, has to be 144 plus y squared. So 81 equals y squared. So y must be 9. Now I'm going to check, is 20 over 15 the same as 12 over 9? And is that the same as 16 over 12? Well, 20 over 15 reduces to 4/3. 12 over 9 also reduces to 4/3, as does 16 over 12. So yes, they are. When I get to the second one, they want to know, is PHY similar to TH or TYH? If this was true, then PH16 would have to correspond to TY15 in the same way that HY, which is 12, would correspond to YH, which is also 12. Right away I can see, hey, that's not true, because this is a fraction and this is just 1. Okay? So as soon as I have one that isn't proportional, I don't even need to check the third. I can say right away, hey, they're not right. My letters are in the wrong order. All right, on this one, we're asked to solve for x. Again, I already have that right angle, and they share this angle, so I can use angle, angle, angle to make sure that they are similar. 5, to remember we're using the entire side, 30, will be the same thing as 13 to 13 plus x. 13 times 30 will be 390. And then I have 5 times 13 plus x. 5 times 13 is 65, so I have 390 equals 65 plus 5x. And now I'm just solving using algebra. So I have 325 equals 5x. And x must be 65. All right, on this one we're asked how many similar triangles there are. So we've got our big right triangle on the outside, and then we're going to have the 2 more on the inside here and here. Okay. This green angle A is going to match up in that little triangle and in that bigger triangle. Okay, so we've definitely got 2 there. This blue one is going to match up with that medium triangle and that bigger one. So again, those 2 will be similar. And then, because we've just proved that this little triangle is similar to the big outside triangle, and this medium triangle is similar to the big outside triangle, then they must also be similar to each other. So all 3 similar. If you're looking for some help on this, there's a few different videos there to walk through the different types of similarity, or you could also just rewatch this.